Hello friends, I am Ganesh. Welcome back to my channel. Today in this video we will learn how to write the program for the human following robot, which is I built in a last video. If you are not watched that video, I will give the link in the description box. You can check it. Now let's start without wasting much time. Before going to the programming part, we should know the working principle of the robot and components used. As you can see, this is the human following robot which is I built in a last video. There is a four possibilities are there for the robot movement. You can see it should go forward, it may be left, right and stop. There is a four conditions are there. For the forward condition, for the forward movement, what are the conditions should be true? What are the conditions should be applied? When the ultrasonic sensor measures a distance more than 10 centimeter and it should be less than 30 centimeter, then the robot moves forward direction. Next, when it should take a left turn, what are the conditions for the left turn? Now we are only considering the IR sensor detection for the left and right turn. When you can see when the left sensor detects any objects means it should go left, or if the right sensor detects any object means it should go right. If both sensor detects the object means it should be a stop, because the object is nearer to the both the sensors, then there is no movement for the robot. That's why we should stop the robot. And for a stop condition, when the ultrasonic sensor measures the distance less than 10 centimeter, then the robot will stop. And when another condition is there, when the both the IR sensor detects any object means the robot will stop. Now another one main thing is motor's directions. Motor's direction, we know that the for the forward motion, all the motors should rotate in a forward motion, right? Let's see for a left turn. For left turn, the right motor should rotate forward and the left motors should be stationary. Okay, now the robot will take left turn easily. So and another one possibility is there for a quick turn. We should rotate a right side motor forward and left side motor in a reverse direction. Reverse direction, then the robot will take turn very quickly. So that's it. Now for a right turn, we know that left motor should rotate in a forward direction and right side of the motors should rotate in a reverse direction. Then the robot will take a right turn. Let's see the remaining components working principle now one by one. At the first look at the L293D motor driver board. Now you can see here it is written that M1 in and M2 in. This means motor 1 input, motor 2 input, here motor 1 output, motor 2 output. That is the inputs. We are going to connect the wires from the Arduino to motor driver board. That are the inputs. If you gives the signals high to the input 1 and low to the input 2, means it produces the motor 1 in a forward direction, that is the left motor, it will produces the forward motion. Both the motors will be connected in a parallel. That's why the motors, both the motors direction will be same. It produces the forward motion. If the input 2 receives the high signal, input 1 receives the low signal, means the direction will be reverse. That is the reverse direction. It will go back. And input 3 and input 4, it is related to the input 3 and input 4 are connected to the right side. That is the motor 2 set. We are also going to connect with the parallel connection. Motor input 3 and input 4. In this same, input 3 receives high signal, input 4 receives low signal, means it produces the forward motion. It produces the forward motion. If the input 4 receives the high signal and input 3 receives the low signal, means it will reverse the direction. It will change the direction. That is the use of the motor driver. We can change the direction anytime in the program. So that's why we are going to use the motor driver board. So in a output, there is a 4 output are there. One is connected to the M1 out, means motor 1 out. That is the left side motor. Left side motors are connected. It is a parallelly connected. In a this pin is connected to the both motors positive, and this pin is connected to the both motors negative. And here both motors positive pin is connected to the this pin, and negative pin is connected to this pin. That are the inputs. I am written that there is a small 1 2 3 4, means it is the input 1, input 2, input 3 and input 4. Now let's see working of IR sensor. There will be a 3 pins are there: out, GND and VCC. VCC is connected to the 5 volt of the Arduino board, and GND is connected to the GND. And now one more pin is there, that is the output pin. The IR sensor continuously gives the signals to the microcontroller. When there is no detection in the IR sensor, means it will give the high signals to the Arduino. And when it detects any objects, it will give the low signals to the Arduino. Remember this point, it will help while writing the program. Now let's see the ultrasonic sensor. There are 4 pins are there. One is a GND, echo pin, trig pin and VCC. I will explain in the next slide. Okay. The transmitter, that is a trig pin, sends a signal, that is a high frequency sound. When the signal finds an object, it is a reflected, and the transmitter, that is echo pin, receives it. It is an ultrasonic sensor. There will be 2 components are there, receiver and transmitter. See, this is the object. The sound wave, the transmitter transmits the sound waves, and the waves finds an object, and it will reflect, and it will receive in the receiver. We need the total time, that is from the transmitter to object and to the receiver. We need this time. Using this time, we will calculate the distance. There will be a calculation is there. We will see in the programming part. Now there is one more component is there, that is the servo motor, that is a micro servo motor. There are the 3 wires are there. One is brown color, red color, and another one is a yellow. Brown is connected to the ground of the Arduino, and red is connected to the 5 volt, 5 volt, and yellow is the signal pin. For the servo motor, we will write the program in a such a way that when the microcontroller powered up, the servo motor start working. It will take a first turn left, and it will back, and it will go right, and it will come to the initial position. This is how going to write the program for this servo. Let us write the program for the human following robot. So we have to initialize some pins that are the, we are going to use the constant int statement, for variable name as a input1, that is in1, is assigning to the pin number 5 of the Arduino. We need a 4 digital pins for the motor driver board, that is a input 1, input 2, and input 3 and input 4. We will assign the input 2 for 4 and 3, 2, and we are going to make this 2, 3 and 4. Why we are going to use a constant int means constant int does not use any RAM. That's why we are using the constant int instead of int type. So now we are initialized the 4 pins, input 1, input 2, input 3, input 4. We will use this variable in the next steps. Now it is completed for the driver. We have to assign the we have to initialize the some more pins that is for the ultrasonic sensor. We will use the constant int statement again. Constant int, we have 2 pins in the ultrasonic sensor, that is one is a trig pin, Now we are assigning the trig pin to the pin number 5 of the Arduino. One more pin is required, that is a constant int echo pin. Echo pin is equal to pin number 10 of the Arduino. Now we are initialized the trig pin to the 9 pin of the Arduino, and echo pin is to the 10 pin of the Arduino. Now we need some more variables called duration and distance that will use in the loop setup part, because we have to calculate the distance using ultrasonic sensor. Now take a long type and variable name as a duration. Now again one more is required, int is sufficient, type int distance. Now it is completed for the ultrasonic sensor. We have one more sensors called IR sensor. We have to define define the pin is connected to the Arduino. That's we are going to use a hash define statement. Hash define. We are going to take the constant name as the left. That is a left sensor. Left means left sensor of the IR sensor, and that is assigned to the A0 value, and hash define write to the A3 pin of the Arduino. So note that there is no semicolon after the hash define statement. Now the all the initialization is completed. We have to move to the white setup part to write the program in the setup part. In the setup part, we will declare the which pin is output and input. For that, we need a pin mode function to write which pin is output and which pin is input. We will use the pin mode function, that is, we'll write pin mode in 1, that is input 1, output. I will explain that. I will change this to input 2, input 3, input 4, and all are output. See, I already explained that we need a 4 pin to the motor driver board. We have to give the input to the motor driver board. That's why we need a output. That's why we have written the output. All the pins should be output, because we are giving the we have taken the signals from the Arduino and we are giving the signals to the motor driver board. That's why we have written the output. Now for the motor driver, it is completed. Now for the ultrasonic sensor, now we are going to use now we are going to write pin mode command and trig pin comma output. I'll explain you why trig pin is output, and we need one more pin mode, that is for a echo pin. Echo pin, we are already defined that trig pin is, see here, trig pin is equal to, that is assigned to 9 number, and echo pin is assigned to the 10 number. Now just we are going to use the, instead of 9 we are going to use the trig pin name, constant name. Now trig pin is output and the echo pin is input. Setup is completed for the ultrasonic sensor. Now we are going to write the pin mode for the IR sensor. Again we have to use pin mode command. Pin mode, we already defined that write constant that is input. We know that why it is input, because the IR sensors detects the any objects and it will give the signals to the Arduino. Arduino will receive the signal. That's why it is input. Let us write we need one more pin mode, that is for left sensor. We have already defined that. See, left is connected to the A0 pin of the Arduino and the right sensor is connected to the A3 of the Arduino, that is the analog pins. Now it is completed. For the IR sensor, we have to write one more statement, that is a serial dot begin 9600. For the serial communication, we have to write this statement. Wide setup is completed now. The part 1 of the video is completed. You can watch part 2 for the remaining programming part.